So now let's take it into Industry 4.0 and the smart factory. So Industry 4.0 comes out of Germany. Like most things out of Germany, it comes out of a consortium. They're a very planful group of people. I don't know if you know that about the Germans. They're very planful. They also tend to try to make decisions in a way that creates standards, and they all kind of follow the standards. But Industry 4.0 is the fourth major reset in the history of factory and factory automation. So just a little background, Industry 1.0 was mechanical production powered by steam and water. 2.0 was in the 19th century. This was the assembly line, Ford. Industry 3.0 was sort of the first use of computers and automation. In this world, they're called programmable logic controllers, but they're really just specialized computers for factory automation. And Industry 4.0 is intelligent production incorporated with the Internet of Things, cloud technology, and big data. So the ability to collect information, the ability to share information, and the ability to use that information to make better decisions and to be more productive, and also to be far more decentralized in the way you control things and the way that you make decisions. So the big things that have changed is that Industry 3.0 was a very centralized control structure. So you had a supercomputer PLC that was talking to relatively unintelligent actuators and sensors, and it was very much go do that thing. I'm telling you to go do it, go do it. In the new world, Industry 4.0, these sensors are collecting information, providing it back to the distributed controller, in some cases directly to the cloud, so that you can monitor activity and so that you can share information in ways that you haven't been able to do before. And I'll give you an example of how that happens. So a lot more connectivity, a lot more sensitivity to build to demand as opposed to build to inventory. And as a result, there's a lot of investment in sensors, a lot of investment in intelligent actuators, and whenever it's economically feasible, the notion of every actuator and every sensor having an IP address is the simplest way to think of it, is that everything can potentially be a source of information for you. So an example that comes to mind is there's an application where remote tank monitoring, for example. It used to be that when you had tanks, so this could be natural gas tanks, somebody would get in their truck and they would drive around and they would check how much gas was in the tank. And they would record it on a piece of paper and they'd bring it back to the office, and that was how you determine whether or not to fill the tank up again. Those tanks all now have a level sensor with a Wi-Fi device that goes back directly. That person who used to drive the truck around and check doesn't need to be there anymore. It's all connected. So these are the terms I use. So the Industrial Internet of Things, Industry 4.0, and Smart Factory. Industry 4.0 is what most Europeans call it. So if you're in Europe, call it Industry 4.0 and you'll be welcomed, because that means you're sort of sensitized and you're acclimated to the whole Germanic community, and they'll understand what you're talking about. Smart Factory tends to be more used in the United States. They're the same thing. It's exactly the same thing. Think of them as interchangeable. They're not really different. Industry 4.0 is just more European. Smart Factory is more US. And the Industrial Internet of Things is really just the extension of the Internet of Things as it relates to leveraging the IP address and leveraging the data that exists in the factory. So what are the major benefits of Industry 4.0? The number one by far is improved productivity, and it's predominantly improved productivity through flexibility and through sharing of information. Second is the ability to have more customized manufacturing. The safety one is interesting, and quite frankly is a direct result of fewer people in the factory. So if you have a lights out factory, you don't have any safety concerns. And being able to manufacture on an autonomous basis is very, very helpful. And then the last is the access for data. So let me walk you through, and I think this is the easiest way to help you understand how the smart factory works. So starting with on machine and on data. The controller itself is connected to all these actuators and all these sensors, and the biggest challenge that you have in the machine is how do you modify or change it over from one to the other. And in the old days, it was entirely mechanical. And if you were going to run, I'll give you an example, Procter & Gamble was a large customer of mine, and in the old days, they had one variable speed drive, and they had a mechanical linkage to that variable speed drive to make a product. So let's use diapers as an example. They would make diapers, and they would make them for days or weeks, and then they might change over if there was another version of the diaper. I remember when I first met them, I think they had 2 or 3 versions of diapers that they made, and they would set it up for two weeks at a time, put it into finished good inventory. Well, over time, their marketing department convinced them that for us to compete, we need more than 2 or 3 versions of diapers. We need, I think they actually went up to 50, and those 50 included, I'm going to date myself, but there used to be a TV show for kids called Barney, or there used to be one called Zaboomafoo or whatever. But they needed to have all these versions of diapers, and therefore the changeover time had to change dramatically. They also, by the way, introduced adult diapers, which was a whole new category, and they had to do more changeover. So with the smart factory and through the connection of the controller and the sensors and the actuators, you have much, much better ability to reduce changeover time and increase your flexibility. The other advantage is preventative maintenance. So on these machines, you have a whole wide range of actuators, the ones you saw in the movie. They're either hydraulic, they're pneumatic, or they're electronic. And these actuators, like anything, need to be maintained. The sensors can feed information back to the machine, and they can make certain that the machine can be maintained in advance of a breakdown. Unplanned maintenance is the biggest impact to OEE in most factories. So you got changeover as an impact to OEE, but unplanned maintenance is a big issue for OEE. And by looking at this information, whether it's vibration, temperature, in some cases it can be the hydraulic fluid, this is all monitored and you're able to maintain it in advance. Then you get to machines talking to other machines. And the obvious question is, why would you care about that? Well, in the old days, the machines before lean came about, you would build as much of some item, subcomponent as you could, without consideration to what the next machine down the line was, even though that would drive overproduction. The machines are now talking to each other, such that if a machine stops, it automatically tells all the other machines to stop as well. Because there's no reason for those machines to continue building product if the machine they're going to send the parts to is not running. So they're now communicating with each other about whether or not they're having problems, and if they are having problems, to change. They're also communicating changeover to each other. So there's, believe it or not, these machines are actually sending information to each other about what I need down the line next and whether or not my machine is running. The third is the machine to the back office. So most people may not know this, but one of the longest dwell times or cycle time considerations in getting a product out of the factory is the amount of time it takes the order to get from customer service to the cell. Doesn't make a lot of sense, but it's actually a pretty big issue. This is now all connected. So in a smart factory, if you place an order as a customer, the order will go directly to the machine that builds it. So the tennis shoe example I gave you, that's all automated. So it goes directly from the website to the machine. In fact, there's a customer we have that is now building a shoe within 15 minutes of receiving the order on the internet. Can you imagine that? And it used to take them a day to get it from the telephone to the factory. And this is going directly there. It's also allowing you to get information back from the factory to the back office to be able to analyze how the factory is running. And then the last is factory to factory. So if you're a large global company and you've got multiple locations that can build the same products, Sometimes you may have a capacity constraint in one area and you need to offload that production to another factory. They're now communicating with other factories. So a factory will signal to another factory that we're at capacity and to begin manufacturing those other products at the other factory. These are all things that would have required sort of human interaction or human intervention in a reactive way in the past, and this is becoming very proactive and very automated. Now, the technology that's pervasive in all this is Ethernet. So Ethernet is the mode of communication that everybody's using. It's obviously what's been used in the LAN environment and the enterprise environment for a long time. Adoption in the factory is increasing. It's still relatively underpenetrated compared to some of the legacy proprietary communication devices. But if you go on a factory floor, you'll see a bit of a smorgasbord of communications. You'll see a lot of legacy standards, but you'll see a lot more Ethernet going forward. And Ethernet is a wonderful technology in that allows you to do things relatively easily, relatively inexpensively. It allows you to leverage off-the-shelf technology that comes out of the IT environment. So whether it's Cisco or HP products, they're all Ethernet-based products. And that's a huge help. And it also allows for remote access. So we're going to talk in a moment, but one of the major benefits of the Internet of Things and one of the major benefits of Industry 4.0 is the fact that people can do things remotely they couldn't do before.